Hello guys, welcome to our channel. So today we are going to continue with our A-level massive revisions. So today we are having this question paper. This is November 2023 session, physics paper 3, advanced level 4, Zimsec. Okay, so this is question paper. It is for towards 30 minutes, and if you are not doing Zimsec, it doesn't matter because what you only need is data. So just pay attention to the data, and if you are doing Zimsec, just also pay attention to the instructions to the candidates. So in this question paper, you are required to answer 4 questions, and number 1 it is compulsory. So today we are going to put more of our focus on question number 1. So question number 1 is compulsory, and it is for classic mechanics and general physics. And question number 2 it is for waves and oscillation. Question number 3 is for electricity, magnetism. Question number 4 it is for matter, and question number 5 it is for modern physics and telecommunications. Okay, so there's another information. There's this data: the speed of light in the free space, the permeability of free space, the permittivity of free space, the elementary charge, the Planck constant, and the rest mass of electrons. So we should take note of this one. 9.11 times 10 to the power negative 31 kg. This is the rest mass of an electron, and Avogadro constant and Boltzmann constant 1.38 times 10 to the power negative 23 joule per Kelvin. There's gravitational constant, and there's also acceleration of a free fall. So you should also take note of this value 9.81. So whenever you are required to use G or the acceleration of free fall, use 9.81. That is the required value for this question paper. Okay, so you are given this set of equations. The ones for uniformly accelerated motion, S equal to ut plus alpha t squared, v squared is equal to u squared plus 2as, and the gravitational potential, the equation for simple harmonic motion. So you should also be able to derive this equation for simple harmonic motion. And there's Doppler effect, there's attenuation of X-rays, electric potential, capacitors in series, and you should also be aware and be familiar with these equations for the capacitors in series and resistors in series, the difference between capacitors in series and resistors in series, capacitors in parallel and resistors in parallel. Okay, so let us dive into our question paper. So number 1 says state 2 base units. So we are required to state 2 base units. So the first thing we need to do is to define what are base units. So base units, these are units that are independent of other units. So we have base units and we have derived units. So base units, these are units that are independent of other units, and we have 7 of them. We have meters, we have kelvins, we have mole, we have candela, we have amps, we have seconds, and also you have meters. Okay, so these are the 7 base units. And there's what we call derived units. So derived units, these are units that are dependent to other units. So derived units, they depend to base units, and base units, they are independent to derived units. So derived units, there are many derived units, like Watt is a derived unit, Joule is a derived unit, Newton is a derived unit. So you should also be able to differentiate base units and base quantities. Because there is another question paper that asks a question to define what are base quantities. So you don't make an error to relate these two. These are two different things. Base units are not base quantities. So base quantities, these are quantities that are independent of other quantities. So examples of base quantities, we have current is a base quantity, but amps, it is a base unit. And if we are talking about temperature is a base quantity, and Kelvin is a base unit. And then from derived quantities, we have force is a derived quantity, we have acceleration, speed, and so forth. These are derived quantities. So in this question, we're just required to state 2 base units. So you can write meter and second. These are just 2 base units, but if you can write as many as you can. Okay, so let us move on to the second part of the question, which requires us to express the unit of resistivity in terms of base units. So we have this equation that relates resistance, resistivity, and length, and also cross-sectional area. So the equation is R is equal to rho L over A, where rho is the resistivity, L is length, A is cross-sectional area, and R is for resistance. So as you can see from this equation, you can simply tell that this resistivity, or rho, is the constant for the relationship that relates resistance with the length of the wire and the cross-sectional area of the wire. To say R is directly proportional to length and inversely proportional to A. And for us to remove this proportionality sign, we then introduce an equal sign and a constant. Therefore, R is equal to rho L over A. Okay, so that is our relationship that relates resistance and resistivity. So for us to calculate the base units of resistivity, the first thing is to make resistivity the subject of the formula from this equation. So we can multiply both sides by A to say Ra, it is equal to rho L, and then divide both sides by L. Therefore, rho, it is equal to Ra over L. So the base units of resistivity, or rho, it is the base units of R multiplied by the base units of A divided by the base units of L. So don't forget to put these square brackets whenever you are calculating for base units, because if I remove these brackets, it's now the base quantity is not the base unit. So you should be aware with this difference between the base unit and the base quantity. Okay, so for the base units for cross-sectional area, they're very simple, it's square meter, and the base unit for length is meter. But for the base units of resistance, we have this equation. V is equal to IR. Therefore, R is equal to V over I. And then the base unit of I is amps, because I is a base quantity. And also, we need to calculate for the base units of V. So V, what is potential difference? It is work done per unit charge. So it's work done per unit charge. And what are the base units of work done? Work done, it is equal to the product of force times distance, and also force, it is equal to MA from the Newton's second law of motion. So the base units of force, it is equal to what? Kg meters per second square. And then the base units of work done, it is kg meter square per second square. And the base units of potential difference, it is kg meter square per second square divided by AS, because charge is the product of current and time. So the base units of V, it is equal to kg meter square per second square. These are the base units for potential difference. And then the base units for resistance, it is kg meter square. It's not here, it's base units for voltage for potential difference, it is cubed here and like this. So these are the base units for potential difference. I have forgotten to divide by AS, the base units for charge. Okay, so the base units for resistance, we are now dividing this by A. So it is kg meter squared per second cubed A raised to the power -2. So this is the base units of resistance. Therefore, the base units for resistivity, it is kg meter squared per second cubed A raised to the power -2 multiplied by square meter divided by meter. Okay, so the base units for resistivity, it is kg, and it's kg cubic meter, like this. So this is the base unit for resistivity. It's kg cubic meter per cubic second and per square amps. Okay, and let us move on to the next part of our question. So the next question requires us to derive an expression for P in terms of A, V, and rho. Given that P is for power, and A is for area, V is velocity, and rho is for density. So we are required to use base units to derive an expression that relates P, A, V, and rho. So you can now say P is equal to rho raised to the power x, and A raised to the power y, V raised to the power z, like this. So the base units of power, it is it is energy or work done per unit time. So it is the base units of energy per unit time, and the base units of energy, it is what? Kg meter squared per second square, like this, and you divide this by second. Therefore, the base unit of energy, it is kg meter squared per cubic second. So this is the base unit of energy. This is the base unit of power. And the base units of density is mass per unit volume, so it's kg per cubic meter. And then the base units for area, it is square meter. The base units for speed, it is meters per second. So let us use these base units to say for power, it's kg meters squared per cubic second, being equal to the base units of density raised to the power x. So it's kg raised to the power x meters raised to the power -3x multiplied by the base units of A, so it's square meter, so it's m raised to the power 2y. The base units of V, it's meters raised to the power z, and second raised to the power -z. So we then now equate the indices to say kg raised to the power x is equal to kg raised to the power 1. Therefore, x is equal to 1. Okay, and then for meters on the right hand side of the equation, we're having m raised to the power negative 3x plus 2y plus z. Okay, and then for second, we are having second raised to the power negative z. Therefore, we can equate this one to the one with the on the left hand side of the equation. So s raised to the power negative z is equal to s raised to the power negative 3. So negative z is equal to negative 3. Therefore, z is equal to 3. Okay, and we are now left with the value of y. So we can now use minus 3x plus 2y plus z being equal to 2 on the left hand side of the equation. So our x is 1, so it's minus 3 plus what is a y plus 2y plus 3 being equal to 2. So 3 by 3 minus 3, it is equal to what? To 0. Therefore it's 2y being equal to 2 and y is equal to 1. So the expression, it is P is equal to density rho A V cubed. So this is the expression that can relate pressure, that can relate power, area, speed, and density. Okay, and let us move on to the next part of the question that requires us to explain the term torque of a couple. So torque of a couple, it is the product. Torque of the couple, it is the product of one of the forces and the distance between the two forces. So when you are having something like this, and there's one force acting in this direction, it is F. In these two forces, they are of same magnitude but acting in opposite direction. So the distance between these two forces is x. So torque of a couple, it is one of the forces times the distance between what? Between these two forces. So it's F times x. That is the torque of the couple. Okay. And what you need to understand on this topic of torque of the couple, it is that this only causes the rotational motion, but there's no translational motion. Okay, so if you are being asked that is this body in equilibrium, because there are two conditions for a body to be in equilibrium. There must be no resultant force, but as you can see here, there's a force acting in this direction, and the force is a vector quantity. So if this force is acting in this direction, and you consider this direction positive, and you also consider this direction negative, these two forces cancel each other, and the resultant force is going to zero. So you might feel that this thing is in equilibrium. Why? Because the resultant force is equal to 0. But there's another condition for your body to be in equilibrium. There must be no turning effect. But for this torque, for this couple, there is what we call the turning effect. So this will be not in equilibrium. Why? For that reason, there is rotational movement. Okay, and then let us move on to the next part. We say state the effect of a couple force on an object. The effect is that there is rotational movement. That is the effect of couple forces on an object. Rotation of what? Of an object. And then let us move on to this part of the question, which says describe the similarities and the difference between viscous drag and friction. So we can write friction like this. Right, friction was and then on this side is a viscous what? It's a viscous drag. Okay, so friction, under friction, it depends on the surface in contact, the nature. So we can say the nature here. It depends on the nature of the surface in contact. The nature of the surface in what? In contact. And then for viscous drag, it depends to surface area in contact. It depends to surface area in contact. So if the surface area is very large, viscous drag will be very high. And then if the surface area is very large, there will be no change on frictional force. Why? Because it depends on the nature of the surface in contact. And then there's another difference that under friction, it is there even for a stationary object, but viscous drag, it depends on the speed of the moving object. So it is 0 when the object is stationary, but frictional force, it is there even the body is stationary. Okay, so these are the difference between frictional force and viscous drag. And the similarities between frictional force and viscous drag is that both they are dissipation forces. They reduces reduces the resultant force, both frictional force and viscous drag. So that is the major similarity between viscous drag and frictional force. Okay, and let us move on to this part of our question, which says Fig 1.1 shows a smooth trolley runway. So we're given a smooth trolley runway, and the trolley is released at point X and runs down the slope, moves in a circular path and travels towards Z. The radius of the circular path is 0.25 centimeters. So we are required to outline the energy changes as the trolley moves from X to Z. So we're required to outline the energy changes from X to Z. So from this point, this trolley, it has gravitational potential energy, and then the gravitational potential energy has been converted into what? Kinetic energy. That is the energy change from gravitational potential energy to what? To kinetic energy. Okay, and then the second part of the question says list all the forces acting on the trolley at point Q. We're going to list all the forces that are acting on the trolley at point Q. So here's the point Q. So there's weight acting in this direction. There's also normal reaction acting in this direction, and we don't include centripetal force. Why? Well, centripetal force, it is the resultant force between normal reaction and weight. So when you ask to define what centripetal force is just the resultant force that keeps objects in a circular path. So we don't include an arrow for centripetal force, although we know that centripetal force, it always takes place toward the center, but we don't include that arrow on our free body diagram. So all the forces that are acting is normal reaction and weight of the trolley. And then the last part of our question says if the velocity of the trolley at point Y, so it says if the velocity of the trolley at point Y is 1.6 meters per second, and we are going to calculate the vertical height h. So if the velocity at this point Y is 1.6 meters, we're then required to calculate the height h. So here we are using the principle of conservation of energy, which says that energy is neither created nor destroyed but transformed from one form to another, or you can just say total energy of a closed system is constant. Okay, so we have been converting the gravitational potential energy into kinetic energy. So it's EP into AK like this, and then EP is mgh being equal to half mv squared. So we can simply cancel these m's. So gh is equal to half v squared, therefore h is equal to v squared divided by 2g. So our height is equal to v squared over 2g, therefore h is equal to, what is our speed at point y? It's 1.6 squared divided by 2 times 9.81, the gravitational field strength. So we can now say it's 1.6 squared divided by 2 times 9.81, and this gives us 0.13 meters. So height h, it is 0.13 meters. Okay, and let us move on to this part of our question. This is part D. So as you can see, this question paper, it was very easy for this number 1 question. For 25 marks, I think this was the easiest question paper you might ever seen. So the part D says Fig 1.2 shows a planet X of diameter 2.3 times 10 to the power 3 meters with a gravitational field strength of 16 Newton per kg at its surface. So this is our planet, and the diameter of the planet is what? 2.3 times 10 to the power 3 meters, and then the gravitational field strength, it is 16 Newton per kg. So we can measure the gravitational field strength in Newton per kg or just meters per second square. These are the same thing because the base unit for Newton is kg meters per second square. So if we multiply kg meters per second square by per kg, these two cancels and we're going to be left with meters per second square. So Newton per kg and meters per second square is the same thing. So we are required to copy Fig 1.2 and draw lines to show the gravitational field. So you can just say put like this. Okay, so gravitational field is always x toward the center like this. Here is our gravitational field acting towards what? Towards the center. So this is the gravitational field. And then the second part says draw the lines to show the equipotentials or surface of X. So the equipotential like this. Okay, so that is our equipotentials in the gravitational field. Okay, and then let us move on to the next part of the question, which says determine the density of the planet. So density is equal to mass over volume. So the mass of the planet, you don't have the mass of the planet, and the volume it is 4 over 3 pi r cubed. That is the volume of the sphere. So we can simply calculate the volume of the sphere because we have diameter, so we can divide by 2. So volume of this planet, it is 4 over 3 pi times 2.3 times 10 to the power 3 divided by 2 cubed, like this. So let us calculate our volume. To say is 4 over 3 pi times 2.3 times 10 to the power 3 divided by 2, and then raised to the power 3. So this gives us 6.37 times 10 to the power raised to the power 9 kg per cubic meter. That is our density. That is our volume. So this is volume. It's cubic meter. Okay, and then for density, we can now say we can then calculate our mass. So gravitational field strength G, it is equal to Gm over r squared, like this. This is the formula for gravitational field strength. So you can simply calculate the mass of the mass of this planet. To say it is now G r squared being equal to Gm, like this. So the mass, it is equal to G r squared over G, the big G. So M, it is equal to 9.81 multiplied by 2.3 times 10 to the power 3 divided by 2 squared all over 6.67 times 10 to the power negative 11, the value of G. So it's 9.81 multiplied by let me do this. It's 9.81 multiplied by 2.3 times 10 to the power 3 divided by 2, and then square everything divided by 6.67 times 10 to the power negative 11, and then our answer is 1.95 times 10 to the power 17. So this is our mass, and then let us divide this mass by this volume. So if we divide 1.95 times 10 to the power 17 by 6.37 times 10 to the power 9, you get our density. So it is now 1.95 times 10 to the power 17 divided by 6.37 divided by 6.37 times 10 to the power 9, and our answer is 3.1 times 10 to the power 7. So this is our density. But you can use another alternative way to calculate this density. Okay, so let us try to use this other way for us to calculate, and this one will be the simplest way for us to calculate the density of this planet X. So given that density is equal to mass, density is equal to mass over volume, and G is equal to Gm over r squared. So the mass is equal to G r squared over G. That is our mass. And then volume, it is equal to 4 over 3 pi r cubed. So let us divide G r squared over G divided by 4 over 3 pi r cubed. So when you are dividing these two fractions, we then invert the second one and put the multiplication sign here. So it is G r squared over the big G multiplied by 3 over 4 pi r cubed. Okay, so it is now G r, so we can just remove this r. So it is now 3G divided by 4 the big G pi r, like this. So it is now 3 times 9.81 divided by 4 multiplied by 6.67 times 10 to the power negative 11 multiplied by pi multiplied by the value of r, that is 2.3 times 10 to the power 3 divided by 2. Okay, so these two, you can shift these two here to say it is now 6 times 9.81. So let us calculate this to say 6 times 9.81 divided by 4 times 6.67 times 10 to the power negative 11 multiplied by pi multiplied by 2.3 times 10 to the power 3, and our answer it is 3.1 times 10 to the power 7 kg per cubic meter. That is our final answer. Okay, so we are done with this number 1 of the question paper of November 2023, paper 3, and for the next video we will be focusing on question number 2 of this question paper. Okay.